Everyone. Thank you so much for coming. We are here. So this is a sort of like a joint research seminar that has been organized in the context of the ADAPT Law and Tech working group, also in collaboration with the European Master in Law, Data, and Artificial Intelligence, in which ADAPT is an associate research partner, and the DCU Law Research Center. And I'm really happy. I mean, we have been trying now for a few months, so
almost a year.
To have Dr. James Steinhoff here at DCU. And James is an assistant professor in the School of Information and Communication at University College Dublin. He holds a PhD in Media Studies from the University of Western Ontario, and is the author of a very interesting, actually, work in the sort of like media field at intersection with AI. So he wrote a book on entitled Automation and Autonomy, Labor, Capital, and Machines in the Artificial Intelligence Industry, that was published in 2021, and also co-authored another book entitled Inhuman Power, Artificial Intelligence in the Future of Capitalism. So especially our master is an interdisciplinary master, so it will be very interesting also to look at artificial intelligence from different perspectives. And this is what we are also trying to do in the context of ADAPT, also for sort of like for the future vision of the center to continue working at the intersection between various disciplines. So without further ado, I will leave the floor to James for his presentation. We are going to record the part with the presentation, and we are simultaneously online. I hope that actually the colleagues who are online can hear us well. And we are going to stop the recording for the Q&A part. So thank you so much in advance for your attention. And thanks, James, once again for coming. The floor is yours.
Great. So thank you, Eduardo, and everyone from ADAPT for having me. Tried to make it across the city for quite a while, as Eduardo said, and finally made it here. So it's great. And great to have this interdisciplinary group, because I actually came to AI originally through philosophy many years ago, and a class called Android Epistemology in my undergrad, which you have to take. Sounds very cool. You know, if you have that option, you must take it, right? So, but anyways, here I am. And I kind of work in political economy of AI. And I'm going to talk today about the paper that I think was circulated before, but I won't really be talking exactly the paper. Either you've read or you haven't. Either way, I'm going to talk around the paper and refer to it, but also talk a bit more about how my research in that same line of thought has gone on since the paper. And broadly, that's going to pertain to something called synthetic data, and its, well, theoretical and broader political economic consequences. So here's the preview, the summary of the talk, is that this thing called synthetic data is driving significant political economic change in the ever-changing AI data economy. And I'm going to argue that this technology actually undermines the mainstream of theory used to understand the AI industry, which is surveillance capitalism. There's different ways of referring to it, but you know, Shoshana Zuboff's probably the most famous one. So we'll take that as sort of the one that I'm talking about if I don't specify. Now, at the end, I'm going to talk about one particular way that you can see some concrete changes happening that are driven by this technology. There's more than one I can refer to briefly, but I'll kind of focus on one, and that's in the labor process and the production process of artificial intelligence, machine learning technologies. I've done research on that. So I actually did my PhD dissertation on the labor process of commercial machine learning commodity production. And so it's something I'm pretty familiar with, and synthetic data is changing that, what we know about how that happens. And then finally, the takeaway conclusion is we need a theory of synthetic, what I'm calling straight now synthetic capitalism, or in the title, post-surveillance, but no one really wants to have a post title. So maybe synthetic capitalism is the theory. anyways, it doesn't exist yet, but I think it should. So we'll follow this pretty hefty looking itinerary here. And we'll begin, well, a quick refresher. Probably here people are well aware of what machine learning is, but in case anyone's not, the simple way of characterizing it is by a sort of change in how data gets used, right? This diagram here shows you that with a conventional program, you would have, right, you write a program, you feed data into it, and it outputs something, an output, right? With machine learning, the idea is well, this is supervised machine learning particularly here, but the idea would be that you have data, you specify what you want to happen, and you have the machine learning learning algorithm output a machine learning model that achieves that function without you having to know how it actually occurs, right? It occurs through this learning process, and that's where all the excitement around machine learning derives, right? You can extract the model from the data without knowing how to actually solve a task particularly. At least that's the hope. Right, but the important part about that is that data becomes more and more important, right? Lots of data. Hello. Now, so two things we need to look at here first that get impinged upon, I will argue, by synthetic data, what you can call two tenets or maybe dogma or orthodoxies now for what I would call broadly critical data studies, which is the interdisciplinary field of people that are from STS, science technology studies, media studies, sociology and beyond, who've come together in the wake of the big data revolution 10 years ago or so. But so one of the things you can see throughout critical data studies research is this sort of point, right? That data fundamentally is people. Now, of course, this doesn't apply to all data ever, right? Particle accelerator data or deep space satellite, giant telescope data that, take things from them, look at the Big Bang. That's not about people directly, obviously, but that's not also what makes money for big tech, right? Who pioneers the surveillance, the data industry. The data that's valuable economically is recordings of what people do on digital platforms mainly, and also in the world through cameras and such, right? So you have a litany here of observations to this end. Jeff Bowker, the famous STS scholar, pointed out quite a while ago now that there's no such thing as raw data, right? Data doesn't just get found in the world like petroleum, whatever, gets produced. And since then, people have focused on the fact that the process of making data involves some kind of recording, right? Sadowski says here, Gregory says it's made of people, rhythms, circulations, mutations of our bodies. Has an inherent humanness. Zuboff says, it's literally human experience as a free raw material, literal mining subjectivity, multi-human, blah, blah, blah. So years of this now, right? This is a widely accepted fact. And it continues to be made in a lot of critical papers, right? Because it's often neglected in industrial and popular discourse about data. Valuable point. But it's connected to a second point, which follows from the first point, is that data intensive capitalism, data that uses capitalism, is thus necessarily going to be a surveillance capitalism. Because if data comes from recordings of what people do, business models based on data are going to have to get data, and they're going to have to do that by recording people, and that is more or less surveillance. And there's different ways of talking about this, right? You might talk about platform capitalism, you might talk about data capitalism, you might talk about surveillance capitalism, but the whole point is that you collect data. Cernicek's formulation is platform capitalism, but he talks about the fact that the whole point of the platform model is that as it's connecting two people in a multi-sided market, the point is that the platform owner can appropriate data on how that happens, and that can often be more productive than the purported main business model. So now the consequence of these things is sort of this corollary here, is that if data is from humans, and then capitalism based on data is necessarily surveillance, then surveillance becomes self-justifying in the same way that profit generation is, right? If you're a company, you don't have to justify why you make profits. That's what you do. You have to do it. In fact, if you're a capitalist organization, if you stop doing it, you cease to exist, right? So you have to do it. And once the data becomes a necessary input for a business, then it becomes self-justifying in the same way. So we have a lot of predictions by scholars in this field that surveillance is going to expand and expand into further reaches of life to collect new kinds of data, thereby to produce new kinds of commodities, new markets, etc. Mark Andreevich, Dave Crawford, many others make this sort of argument. So surveillance will intensify. But there are a lot of reasons, well, there's a lot of obstacles to this particular business model, even as it spreads, right? So there's the term, the techlash, which I guess nobody uses anymore, but it was a term about 18 years ago when people started, when the tides turned basically on big tech. Big tech was regarded warmly by many people for quite a while until maybe mid 2010s, the 2016, when all the scandals happened and there was a big backlash, the techlash. And since then, nobody really trusts them anymore. It's quite why it's quite common now to be dubious of Facebook and what Google are doing with your data. But in any case, that was a contributing factor to regulation. We know, presumably everyone here is aware of the GDPR and the emerging AI Act, but those are only two examples around the world of different kinds of regulation that pertain to the commercialization of data. And in more or less, depending on the ones we look at, they put some obstacles to the surveillance capitalism model. Perhaps not as many as we'd like, but some. But that's not the only obstacle facing this paradigm. There's also, I mean, despite what you would think, and despite the fact that we are apparently immersed in more and more data, exponentially more data than the world ever has been, if you speak to some computer scientists or people working in machine learning, or businesses that are working in putting up machine learning commodities, there's a lot of talk about there not being enough data. In fact, there's insufficient data. And Forbes, any business magazine will have tons of examples of this, as will industry practitioners. And those pertain, one, to regulation again, but it also pertains to the fact that some areas, as the surveillance capitalism model, platform capitalism model expands to, some areas just historically don't have a lot of digital data, right? Until pretty recently, for instance, agriculture didn't produce very much data because there was no sensors to collect it, right? So, so this is a concern by people working in this area. Now, I'd also argue that there's the structural pressures on this model. Now, it's been observed for 150 years at least that the competitive nature of capitalism, capitalist firms compete against each other, compels the increase of productivity, increase of efficiency in individual firms. This, most well-known of this is the automation of production, right? Speeding up productivity of laborers. Think of assembly lines, just think of automation generally. But in fact, this doesn't only happen in production, it also happens in other aspects of capitalist production, including circulation, which is getting the commodity from the production place to the consumer, right? So you have inventions such as the standardized shipping containers in like the 1960s or so that massively sped up how fast the commodity goes from factory to the store and then thus to the consumer. So circulation also gets sped up. It's compelled by the same logic. Now, the actual consumption of the consumer buying the commodity and getting the commodity home from the shop has also been accelerated over time. The recommendation engines that Netflix pioneered are a prime example of this, right? You don't have to search through every page of Amazon if you want to buy something on Amazon. Search algorithm for one, and then Amazon just recommends to you what it thinks you're most likely to buy. speeds up the process. Now, the argument I make in the paper at length, and theoretically I'm not going to do here, is that in the provision of data, this is the same logic of acceleration also is applying, and synthetic data is an example of this. So for this business model fits surveillance capitalism for increasingly automated forms of production which use machine learning and such things that require data as an input, there should logically be an impetus to accelerate the provision of data. So this is not the automation of production or circulation or consumption, but it's actually the automation of the conditions for machine learning automation. Much easier to read. It's a bit of a mouthful, but that's the key argument. That's the essential argument here. So what actually are we talking about? Could anyone raise a hand if they are familiar with the concept of synthetic data? Got 2, 3, 4, 5. Okay, couple. Yeah, great. That's more than usually I get when I talk about this sort of stuff. So that's great. So we can look at some definitions here. I think one's from an NVIDIA blog, the graphics, the GPU manufacturer, and one I think is from IBM page here. We see that it's data that's artificially created rather than being generated by actual events, or it's data that computer simulations or algorithms generate as an alternative to real-world data. All right, so we have a binary opposition set up here. But, what does that actually mean? Well, it's instructive to look at one big synthetic product that you've definitely encountered in day-to-day life, right? Car tires used to be made completely of latex from this particular tree. Now they are latex is somewhat used, but I think the majority of the chemical composition comes from petroleum byproducts now, right? So you can just synthesize rubber through a chemical process rather than a simple whatever the previous form was. Now, how does that apply to data? Well, there are at least 3 ways of doing this as far as I can tell, and maybe a 4th one, but we won't talk about that today. If you're interested, we could talk about that later. Now, these are by my own. This is my own really non-scientific rating here, from least to most synthetic. But we'll go through them in that order, and hopefully that will make sense. So the least synthetic way of doing this is what's called data augmentation. And this is arguably not even synthetic data. It's sort of a boundary case, depending on who you ask. But mainly it involves making automated minor changes to data such that you can expand a particular data set by a large degree, right? So you can see here, say the image in the top left is the initial image you would have, one image in a data set. Data augmentation would be using some sort of procedural algorithm or procedural thing, or something that basically goes through and applies maybe a couple 100 different sort of filters or modifications to the initial image, because a machine learning algorithm does not know that those are the same. If the pixels are different, it's a completely new data point to the machine learning algorithm. So you can turn one here into at least 1064 according to the paper. That obviously is great for training a machine learning model. See another example here. You can turn one number 6 into all kinds of different inputs, vastly expanding your data set, and cheaply as well. So this is far from like a science fiction technology. This is ubiquitously used in computer vision. Pretty standard, not very high tech. And not really what's driving all the excitement around synthetic data at this point. Now, one of the more, the cutting edge ones, let's say, is using the generative model, something like what is behind the chat GPTs and the stable diffusion image synthesis algorithms and such. I'm not really going to delve into the mechanics of that here, I don't think, because it's pretty hard to explain. But the the main point of this is that it's still like the data augmentation relies on taking an existing data set, basically running it through a set of generative models which extract the relevant statistical properties from that data set, and can reproduce the relevant statistical relationships in a new data set, but with the other parts that you don't want to be preserved changed, right? So if you think about this in terms of medical data, for instance, you may want to run clinical trials and analysis, but you want to make it so that it's not reverse engineerable to discover who's involved or something. That's where the big excitement is about this. This one's mainly concerned about, you know, anonymization and privacy applications. But I'd like to focus on this third way of doing this instead, partially because it makes for better visual demonstration. But this is using a simulation, and it's a very different way of making synthetic data. So if the generative model approach involves sort of synthesizing new data by extrapolating it from an existing data set, simulation doesn't rely on an existing data set at all. So, but it doesn't generate data from scratch. Instead, it involves capturing data, but capturing within a virtual environment. So that so the one that Facebook is working on here, Habitat Sim. Go through this in a bit more depth, but we initially can know that obviously this is very appealing for an application like an autonomous vehicles. As you probably have heard, autonomous vehicles have like killed a couple people now. Recently, a dog, I think, in California got ran over by one of Uber's or someone's. So, you know, to pilot an autonomous, to have an autonomous vehicle drive itself, you're going to want it to gather data, but obviously that's quite dangerous in the real world. So there's an appeal to generating simulations as places to collect data. And that is what we're seeing. And autonomous vehicles are definitely the leading application the main application that people are interested in using this for right now. And so interestingly, or maybe not surprisingly, attempts have been made to repurpose existing simulations for this purpose, including Grand Theft Auto, right? The right hand there. And this is a VR application. People are doing the same thing there. But there are, of course, limitations to 10-year-old video game engines, and virtual graphics have massively, well, they're kind of at the point of near, you know, photorealism if you have a fast enough computer. And so there's a whole subsector of industry popping up to build custom design simulations for this very purpose. So the actual leader in this, surprisingly, is NVIDIA, who is, was originally a graphics GPU manufacturer, graphics processing unit, sort of the chips that were made for computer graphics, but also coincidentally were found out to be great for running machine learning applications. In the last handful of years, they've moved into not just making hardware anymore, but to getting into this emerging simulation market. And that's got some interesting implications on its own here. Yeah, we'll return to that. Let's see if this will work. Okay, it will, here. So this is NVIDIA's Drive Sim. Now, if you're using real footage from the real world, somebody would have to go through and do this task called segmentation of, well, separating the different objects so the computer vision algorithm can separate them. Also, it's just pretty impressive how realistic it looks. But you have, so that there's also radar there, so you have multimodal sensors, not just the actual camera. Because autonomous vehicles rely on radar, LiDAR, other, you know, a couple of different arrays of sensors, lasers, I think, too, different kinds of lasers. synthetic simulated deer, you have simulated cops, simulated accidents. There's the radar. That's the segmentation there again for chopped up. Simulated pedestrians. Built-in randomization, so obviously that increases the amount of data, again, the same way data augmentation would. Yeah. It's quite aesthetically pleasing as well, I think. But you may not only want to simulate urban environments, you may also want to simulate people, like the pedestrian indicated there, because facial recognition is another big application of machine learning. And one of the things that many people have, many people's avenue into being disturbed by surveillance capitalism and machine learning has been to hear about, images of faces being scraped off the internet used to train machine learning algorithms. So of course, people are working on ways of doing that without scraping people's faces. And this is a research from people at Microsoft, where they created some faces, 3D models of faces that never existed, used them to train facial recognition models, and then deployed them in the real world, and they work pretty well to recognize faces. There's also this pretty horrifying example here of synthetic eyeballs being used to train some sort of horrific dystopian eye tracking software, presumably. And I really don't know what data they're trying to produce here. This company, DataGen, so they're simulating a meeting. I'm not really sure why. But so these simulations will involve full physics engines, and varying levels of, accurate refraction of light, this and that. We could go on, depending what the application is. These ones are clearly advertising the skeletons of their models for some reason. So, whoops. So that's how it's made. And the first book on this in the technical literature only came out in 2021. Nikolenko, I think I cited it earlier. It's being talked about in computer science papers for a while, but only last few years is it hitting outside of sort of industry magazines. So you have this opinion piece in Nature and such. And the claims being made for synthetic data are pretty massive claims. They claim that it will fix bias and privacy, which are two of the sort of biggest concerns with these kind of technologies, and with the with machine learning and with data intensive technologies generally. Of course, there's already some research that disputes these claims. But another big claim is, of course, the economic claim, as I mentioned earlier. So labeling machine learning data and chopping this and that manually is a really time-consuming task, outsourced to people with Mechanical Turk and other sorts of things like that. But in a simulation, you don't have to do that at all, because these are existing in a 3D environment. There's distinct, discrete models. The computer already knows where they end down to the pixel, so you don't have to separate the different entities for the computer vision algorithm. They're automatically done. This is a huge labor cost reduction. So that alone makes the technology very compelling to a lot of different potential businesses. Now, there's an interesting sort of technical problem, which is also an epistemological problem, arguably, that all these things, these approaches face. And it's actually called the reality gap by people working in the technical side of this. And mainly it's the fact that if you train a machine learning model on data that does not come from the real world, you don't know if it's going to function in the real world. You hope that it will. But this is a very interesting and generative, I think, line of thought for people coming from any different, any backgrounds, really, philosophical, technical. I just want to point it out here because I think it's really, really deep, and you can. It's just very compelling. I'm not going to say much more on that now, but talk about it perhaps later. So what's actually happening in terms of the political economy of synthetic data? Well, around 122 companies around the world right now that are like startup companies that are producing some kind of synthetic data commodity or intending to. They're concentrated in usual places for tech companies. So the US, Europe, UK, Israel, Canada. And usually they focus on one of those three techniques that one of the two. They usually focus on generative models or simulations. The curious thing is that so far, big tech has not done its usual thing of slurping up the startup companies. I think there's only been one acquisition in this sector so far, which is something that's probably worthy of research right there. I would guess that they're waiting until the technology gets more mature, but I don't know. In general, the big tech companies do not have commodities on the market for this that I'm aware of, except for IBM's. It's actually quite strange how little they're talking about this for some reason. They are using it internally based on blogs. You can see that they're using it. And a lot of non-tech companies are actually using this internally already. Any data intense company, insurance companies, I'm forgetting other ones now, but auto manufacturers are very interested in the simulation stuff as well. But okay, these are in the wrong order, so we'll just come back to that. But so what else can we see happening at the industry level? Well, one, NVIDIA is now valued on par with the tech companies, which is pretty shocking. It's happened in the last month or two. Well, May, I guess. So that's the first time that NVIDIA hit that level, but now I think it's just basically up there, driven by the interest in the simulations that they're producing. So we have it's quite odd. This is a chip manufacturer now valued on par with the 4 or 5 tech giants who lead industry research in AI. Now, this is something people are talking about. It's not a change that's actually happening yet, but it's one that some people think will. And so people are probably familiar with the idea of a data moat. Like the big tech companies have a moat insofar as their data resources, their data collection, and their data sets they already own are so vast that they function as a sort of defensive moat, basically keeping potential competitors off the playing field, right? How are you going to compete with Google's data? As a startup, where are you going to get that much data? Now, the argument is that synthetic data will be a bridge over the moat, right? It will allow you as a small company or let's say an organization or something to just create the data that you need, for a particular application and upset the sort of dominance of the oligopoly of big tech. We can talk about that later as well. I'm not convinced personally. Also, there's not much research on this yet. Well, none real research on this. Synthetic data may be less computationally intense in the long run and more ecologically sound. At least that's the argument being made here by one of these sort of indie large language models being made as a competitor to the big ones like OpenAI's ChatGPT. And apparently it's trained with a lot of synthetic data with a much lower computational cost. So we'll see. Sounds great. Hopefully that's true. Now we'll zoom in on one particular change, as I said, in the labor process, the last couple minutes here. So you can sort of sum up making a machine learning model, at least in the commercial setting, something like this, getting some data, processing it up, training up a model and deploying that model, putting it in a website or cloud or something, and then maintaining it down the road. That's mainly how it works. But of course, if you're collecting synthetic data in a simulation, somebody has to build a simulation. It's sort of a trivial observation, but it actually, I think, has really big consequences due to the question of the reality gap. And if you're collecting data in a simulation, what is in the simulation? How do the pedestrians function in the simulation? If you're going to collect data on how pedestrians move and use that to train an autonomous vehicle, it's quite an interesting question. How do the pedestrians act? What do they do? Not to mention, what do the stoplights look like? The signs the right shape, right? Stuff like this. But anyways, it's a big, I don't know, it seems trivial, but it's also not trivial. It's also the opposite of trivial, I would argue. And there's a whole sort of I don't know how many subs are we at now, but subsector of industry now around building simulations. And this is a chunk of labor that would have been employed in video games sector most recently, and maybe in films or such like that. VFX, like virtual effects, I guess is what they're called, that make the actual sort of 3D models and such. That's what VFX is. There's also this really interesting role called technical artists, who are like half engineers and half artists. I can't delve into my research on that right now, but we can talk about that after too. But already in this emerging industry, the dynamics to increase labor productivity are happening. So you have automation tools emerging again in this sector. I don't think this video is going to work here, but basically the idea is that as simulations, the ambitions of these simulations grow, they become non-trivial to make, especially for one 3D artist. If you want to build a whole city, or you want to have accurate physics, or you want to have this and that interacting, it becomes a bigger and bigger task to produce a simulation. So of course you have automation tools arising, and then this brings up all the questions around automation and labor and management that are perennial questions of political economy. But again, as a precondition before the labor process of machine learning ever happens in the first place. Oops. Is it going to play? It is. Okay. So you can just visualize here. Recently developed a tool for automating production of 3D environments. There's even some automated ways of extracting data from open source maps, like open maps, and ripping data out there and having an algorithm that translates that automatically into a 3D environment. So you have some weird ways where the real world is getting reproduced inside a simulation automatically. Anyways, there's a lot of entanglement going on here on a lot of different levels. So I shall wrap up, as I think we're almost at 45 minutes here. So obviously the synthetic data is nascent technology, quite niche as well, but it's worth thinking about what the broader consequences might be if this technology diffuses as some of the analysts predict it will. I can't believe I didn't include it. There's Accenture and Gartner, if people are familiar with these consulting firms, both of them are really bought into the synthetic data stuff right now, making crazy predictions. Like, I'm pretty sure they predicted by next year, synthetic data will be used more than conventional data in training machine learning models. That's definitely not going to happen. As far as I can tell, I don't think. But they are saying things like Gartner says by 2030, synthetic data will outnumber conventional data or something. In any case, I forgot to bring that here. But we don't have to say that is going to necessarily happen, but it is worth thinking about what would happen if there is a large-scale shift towards data synthesis. Obviously, that impinges on the surveillance capitalism theory, which is sort of underpinning a lot of research right now. So for academics, behooves us to think about the theoretical thing, but also on the practical level, political, economic level, governance level, because all the data regulation is being written for surveillance capitalism, basically. And I will note that synthetic data does get one mention in the AI Act draft as a privacy technology. It's kind of, a throwaway. It's really quick in passing, but it is mentioned there briefly. So, oops. Yeah, okay. Yeah, so I'm going forward attempting to do a comparative study of the introduction of synthetic data to a couple different data intensive economies, drawing on this socio-technical transitions approach mixed with political economy. And that hopefully will produce some interesting case studies, comparative analysis, and hopefully a anticipatory general theory of what synthetic capitalism might look like. So that's it. And thank you is in Portuguese.